All right, this is our first double popper penguin. All right, so let's just whittle away at this thing. The 9 and the 3, I think this is the only place we can start, right? This guy is 9 and 3 is 12, right? And now we've got the dyslexic's nightmare. It's 12 and 21. Are they really different numbers? Okay, but those are parallel, right? So that's going to be left parenthesis 21 to the minus x to the minus 1 plus 12 to the minus 1, the whole thing to the minus 1. That's 7.63 repeating ohms, right? Now we've got 7, that, and 13, right? Seven plus that, right? Okay, so I'm going to go 7 plus the answer I just got plus 13. And I get 27.63 repeating. And then that is connected in parallel with a 17, right? So that's going to be 17 to the minus 1, the parentheses, plus this to the minus 1 to the minus 1. Those are parallel, right? So left parentheses, 17x to the minus 1 plus the answer I just got to the minus 1, the whole thing to the minus 1. I'm getting 10.525. And now we're set, okay? Now I've got 37 volts, and it's a series circuit. It's 37 going through, pushing it through 4, 10.525, and 6. So now I can solve for A1. A1 is V over R, and our voltage is 37. And then our resistances are varied. Let's see, 4 plus 10.525 plus 6. All right, I can do this. 37 divided by left parenthesis 4 plus the answer I just got plus, I just went up arrow and grabbed that, plus 6, end parenthesis, 1.8026 amps. And we're going to use this over and over. 1.8026 amps. We're going to use that over and over again to figure out things. Well, we'll use it at least once. All right. Sometimes more than once. Okay, so right now with that current, I can pick off V1 and V2, so let's do that. V1 is easy. V1 is IR, and the I is this, and the R is 6, right? So 1.8026 times 6. That is 10.8158 volts, okay? So that can go in here. Okay, so that's V1. Now V2 is, we're going to use that. V2 we're going to use to figure out everything inside this circuit here. So V2 is IR, and it's the same current, 1.8026, but then my resistance is this guy, right? 10.525. So let's figure that out. Let's grab that guy, times this guy. .525, there it is. And that is 18.9736. All right, V2. $18.9736. Okay, this is awesome. All right. All right, what do we got here? We got to fence it all off here. Okay. V3, I'm not ready to get V3 yet. Okay. Now, let's figure out some other things. Now that we know V2, we can figure out V2 is what's pushing current through the 17 ohm. So let's figure out the current through the 17 ohm. I 17 ohm is just going to be V over R, right? Literally, it's going to be this voltage, V2, divided by 17. Okay, so whatever we got on that voltmeter, that potential is driving current through the 17 ohm resistor. So that's going to be 18.9736 divided by 17. And that's 1.1161. Okay, so current through there is 1.1161 amps. Okay, that's good. We got that. Let's find the current through the 7 ohm, because the current through the 7 ohm is the current through this 7.63 resistor and is also the current through the 13 ohm resistor. Okay, so let's figure that guy out. So I 7 ohms, the current through the 7 ohm resistor, is equal to V2, whatever we got for V2, divided by this whole resistance here, which is 27.63. It's 7 plus this plus 13, right? So that's 27.63. And that voltage is 18.9736 divided by 27.63 repeating. So I just got to find those numbers. I'm going up arrow in my calculator. There's the 18.9736 divided by, and now I got to go up arrow until I find the 27. Where is it? There it is. I found it. All right, that is 0.6865 amps. All right, now let's see. Hold on. What else can we figure out? Well, I think now we can figure out V3 because we know what this current is in this branch here, so we can do IR to find V3. This will be our, our double popping, right? We're gonna have to pop into this thing here, right? So that's going to be, V3 is going to be that current that we just figured out. The current going through the 7 ohm, which is of course the same current that's going through the 7.63, right? Times 7.63 repeating, right? That resistance right there. So that guy times where is it? There it is. I found it. That guy times that. That is 5. Oh, and this I that I'm using here, that is, I'm using this value here. That's what's going in there. 5.2427 volts. Okay, so that calculation for this was 0.6865 times 7.63 repeating. That's 5.2427 volts. There we go. Okay. So is that, oh, that's a space for it there. 5.2427 volts. Okay. This is looking good so far. Let's see, what else do we have? Okay, the current through the 21 ohm. Well, the current through the 21 ohm, that is just the V3 divided by 21, right? So we know that the potential from here to here is 5.2427 volts, right? And there's 21 ohms of resistance here, so that current's going to be just this divided by this. So that is 5.2427 divided by 21. And that is 0.2497 roughly is what I'll say. So 0.2497 amps. All right. Okay, what else do we have? Current through the 9 ohm. Ooh, that's going to get tricky. Okay, so the current through the 9, let's do those over here. Current through the 9 ohm, and that's just going to be V3 divided by 12. Okay, because we know the potential from here to here is 5.2427, right? And in the path of this, there's only 12 ohms of resistance, right? So it's going to be 5.2427 divided by 12. That guy divided by 12. That is 0.436. It's like 8 nines. So I'm going to say 4369 amps. So that is the current through the 9 ohm. Okay, and the reason I'm dividing by 12 is that there's a total of 12 ohms there, right? So 0.4369 amps. Did I get that? Well, I'm getting them right. Okay, so finally, the final thing, we get down in there, right? What is the voltage across the 3 ohm, right? Well, that's going to be V3 ohm is going to be IR, right? And it's this current. The same current that's going through the 9 is also going through the 3, right? So it's 0.4369 times 3. So the number on my calculator times 3. And that is 1.3107 volts. All right. Woo-hoo. I have room left over to draw a pretty pony. So again, you use, and I'll always put voltmeters across where you need to like calculate. But even if there wasn't a voltmeter there, you'd have to figure out the voltage across that little sub-circuit to figure it out.